High voltage takes center stage in this season of Hitachi Energy's Power Pulse podcast. We promise to bring you great content from the brightest minds in the business. We'll discuss challenges, opportunities, and all the hot topics any high voltage enthusiast, or anyone interested in sustainability for that matter, is sure to enjoy. In this episode of the podcast, we are joined by Uğur Yaşa, Global Product Marketing Manager for the Global Product Group Grid Components at Hitachi Energy. Uğur holds a degree in electrical engineering from Yildiz Technical University in Istanbul and an MBA from Solvay Business School in Brussels. He'll tell us about power quality, its importance, and how Hitachi Energy is addressing this challenge head-on. We'll also get the inside scoop on how their innovative products are helping to prevent wildfires. Hello, welcome to Power Pulse. I'm your host, Barbara Freitas-Daniels, and today I am joined by Uğur Yaşa, Global Product Marketing Manager for the Global Product Group Grid Components at Hitachi Energy. Hello, Uğur. Welcome.
Hello, Barbara. How are you?
I'm good. How are you?
I'm good. Thanks for having me.
Thank you. Thank you for coming. Delighted to have you here. Before we get stuck into the topic at hand today, I hear you're into restoring old watches. What is that about? What draws you into it? What kind of watches? Very interested.
So I have been into watches since I was young. Mm-hmm. So I started first being interested in how a watch actually works. Then I realized there is a difference between quartz and mechanical watches. Yeah. Then immediately I direct my interest into mechanical watches. When you enter to that world, it's a large world, right? So you first learn how it works actually. Then you learn about the brands, you learn about the vintage watches. And after a point, it's not enough. Then you need to dig into it. So you open up the cover and then you see what's actually going on there. So I like to play with watch mechanisms to fix them. It's like an art to me. So it is always fascinating to see in a small area how much art you can fit in. Mm-hmm. It's also quite interesting to see how to find an issue. The watch is not working and then to make a plan to fix it. Right. And to be able to fix it. And after that, start hearing the heartbeats of the watch again. That is quite satisfying.
Yeah. I can imagine. That's fascinating. Yeah. And so that's what you do in your free time. What about work? Will you tell your listeners a little bit about your job and what your role is at Hitachi Energy?
Yeah. So I work for the product group called Grid Components in high voltage. So we manufacture products for high voltage substations mainly. So there are products like instrument transformers for measuring voltage and current to be able to bill the energy to the consumers. Mm-hmm. We have disconnectors to make sure that we have a secure disconnection from the network just in case it is needed during the maintenance and so on. We have cable accessories to connect the cables to each other to make a termination of the cable by the end of the line. That is quite essential for cable connections. We have cooling systems to cool down the converters, cool down the cables to make sure we have a more efficient way of transmitting energy. And we have surge arresters to protect critical equipment on the network. Right. And we have power quality products that is avoiding us to have the bad effects of poor power quality.
And you mentioned power quality. What exactly is power quality? Why is it so important for our electrical systems?
We all use electricity everywhere, at home, in the industrial plants and so on. And we always make an assumption that the electricity will always be there continuously with high quality. But often the reality is not the case. Due to the new types of loads that we are using in the network, there are a lot of pollutants like LED lamps, the computers, the sophisticated medical equipment, some industrial devices, even like EV chargers that we are using. All those devices are creating types of pollutions in the network that is impacting our equipment quality, equipment lifetime, operations, and even human health in a bad way. Typically, we talk about three main categories of power quality problems. Reactive power and extra loading of that, creating on the network.
Okay.
Harmonics, that's a kind of pollution that is we see almost everywhere. And voltage fluctuation, that is impacting the voltage quality on the network. So for everybody to understand a little bit better. So reactive power is like an unwanted type of power that we draw from the network and it is loading the network unnecessarily. Then we cannot actually pull the active power that we want to have to get the things done from the network less. Giving an analogy to that could be a car driving on the road, a flat track road. So if the road is completely horizontal and flat, the car is having a good journey. Once you have ups and downs, some bumps on the road, then you are still getting from A to B eventually, but the journey is not being enjoyable anymore, right? So these bumps can be considered as a reactive power in the network. Actually, there are ways of compensating that by putting some equipments. Therefore, you have a better journey.
What kind of equipment?
We will come to that. So capacitors and filters, basically, we'll be addressing to that. For the harmonics, in fact, it is more day-to-day we have an idea about harmonics, not maybe in electrical field, but in the audio field, musics. So imagine you are listening to your favorite music and there is a bugging buzz happening on the background. So you're still listening to your music, but this buzzer on the background, this disturbance is annoying you. So that is actually what you're hearing for is harmonics. And the same is happening in electrical network. When it comes to voltage fluctuation, that can be a very big headache, what we call flickering effect in lights. Probably you have heard about that. So sometimes the lamps in your room is flickering, right? Going up and down.
Can give you quite a headache.
It can actually give you a literal headache.
Yeah.
Exactly. So power quality can impact not only financially, but also human health in that sense.
And so what happens if you neglect power quality issues? Can you give us some examples so that we might understand in more real terms what it means?
The first and foremost impact of poor power quality is financial impact to the users, to the network. Poor power quality can cause equipment malfunction, loss of lifetime of the equipment, and also extra losses and heating on the devices. So especially for the sensitive devices like computers or medical devices, poor power quality can impact the outcome, the results of those measurement devices quite badly. You can have a CT scan at a hospital that is basically telling you that you are not living anymore because of poor power quality. So the so distorted results eventually. In a typical industrial plant, because of poor power quality, you can have interruptions. As a result of that, you have a lot of financial losses. Imagine a food industry that you have a conveyor making, pasta for you. And as a result of that, you have an interruption and then the whole batch has to be scrapped. This is a huge financial loss. We have seen factories not being able to connect to the grid because of harmonic pollution, because the grid operators are not allowing them to do so. Those are basically the commercial impact of poor power quality. On the other side, there is an impact on sustainability of poor power quality. Poor power quality often comes with extra losses. Extra losses are creating extra carbon dioxide emission to the globe because simply we are generating majority of our electricity today from fossil fuels, right? That's why it is quite important for networks, for industrial plants, and for even commercial installations to improve the power factor and harmonics filtering.
And could you tell us now about those capacitors and filters that you mentioned previously? How do they help improve power quality?
Definitely. Power quality solutions can be starting from a simple capacitor added to the network.
Okay.
That capacitor is basically helping you to improve your cosinus phi, which is power factor eventually. So in the past, 50 years ago, that was an enough solution for improving your power factor. Today, with the new loads and new network conditions, that's not enough. You need to make it a little bit more sophisticated. Then it is becoming harmonic filters, passive harmonic filters, which is a resonance circuit that is filtering the harmonics from the network. Still passive equipment, quite efficient, but there are some pitfalls. It cannot be flexible. It cannot be scaling up very easily and so on. Therefore, roughly 30 years ago, we have invented a new technology called active filters. That is power electronic based technology with some sophisticated software on it that can actually filter harmonics in different harmonic frequencies, make power factor correction, and also some voltage balancing. We today have the full-fledged portfolio for active harmonic filters and still in the market leader position for this technology. That's quite helpful and a flexible way of improving the power factor, filtering harmonics and making some voltage balancing in the electrical installations, especially for industrial plants, commercial applications, hospitals, and so on.
Okay. Sustainability has been a recurring topic in our podcast. Do you have any other initiatives or products that address sustainability in the power grid?
That's a good question. As we said, poor power quality costs you extra energy spent. So this is losses, what we call. So the moment you improve all those harmonics and power factor and you balance the voltage, then you have less losses. Basically, as a result of that, you have less carbon emission to the network, right? That's for the power quality part of it. In our product group, we have also other solutions, as I mentioned in the beginning of the discussion, like cooling systems. So once you have a large data center and you need to cool your servers down, that is basically helping to spend less energy on the data center. As a result of that, you are helping for the sustainability of the environment. We have surge arrestor family that is protecting critical equipment. Usually those equipments are also expensive equipment in the network. In case of an overvoltage situation, so you use a surge arrestor to protect those equipment. If your equipment is still safe after a surge, that means you don't have to replace it. That means it is more sustainable and more long-time equipment usage. This is just helpful for the environment. Surge arrestor as a whole is another topic to help sustainability in a different way. As we all know, we have a reality of wildfires that is happening as we are speaking right now. We have a specific solution in surge arrestor family, what we call spark prevention unit, in short SPU. That is a quite interesting solution to help our sustainability efforts.
Right. If you'll allow me to ask you to delve a bit deeper into the spark prevention unit, so the SPU, can you tell us exactly what this specific surge arrestor does and how it helps prevent wildfires?
Maybe starting with how a surge arrestor works would be a good start, right? So surge arrestor is an electrical component that we connect in distribution and transmission network. That is a simple device that is showing a low impedance in case of overvoltage situation, a voltage surge, which can happen due to an atmospheric condition like a lightning or simply switching a large load in the network. So you have a voltage spike, and this voltage spike can be quite dangerous for the critical equipment like transformers, like converters, and so on. Surge arrestors are equipment being used to show low impedance to these high voltages, to bypass itself basically, to route the fault current through itself, somehow kind of sacrificing itself to avoid these critical equipments are getting damaged. A surge arrestor can do this activity several times in a row in case of normal operation. But sometimes a lightning can be quite severe. And as a result of that, the overloading of a surge arrestor can be significant. In case of a surge arrestor is thermally overloaded, it can actually have a very catastrophic end of life, which is creating some sparks, some hot particles going around, and so on. So these surge arrestors are being used in distribution network. And distribution network is the network that you see when you are walking in the city, as well as they are going through the forest, for example. Fire-prone areas. So in case that end of life of a surge arrestor is happening in a fire-prone area and these sparks are going everywhere, it can actually ignite a vegetation fire around. That's a very critical issue.
So geographically, where are these mostly used?
Wildfires happening all around the globe. So statistically speaking, there are more than 100,000 wildfires happening in the USA and Australia every year. This is huge.
I know.
In Europe, as we are having this record right now, today there are wildfires happening in Turkey. There are wildfires happening in Greece. So we use SPU usually in fire-prone areas in the USA and in Australia quite extensively. And so how the technology works, maybe talking about that would be interesting, right? So what's an SPU? What is spark prevention unit? This is an accessory essentially to a surge arrestor. It's connected to the bottom of the surge arrestor. That is monitoring the thermal loading of the surge arrestor. And in case of things are going to the wrong direction and surge arrestor is going to explode, surge arrestor is operating, disconnecting basically surge arrestor from the network. And as a result of that, the catastrophic event is not happening. So unlike the other similar solutions in the market, we don't try to control the sparks. We just pretend sparks are happening at all. That is the main value proposition of SPU.
Okay.
As a result of that, we believe we have already avoided a lot of wildfires over the last 7-8 years that we have been installing that product. We have more than hundreds of thousands of units have been installed in the US and in Australia as of today. Maybe an information for the audience. Each year, because of wildfires, as we are speaking of sustainability, each year there are 5 to 8 billion tons of CO2 are added to the environment due to wildfires. Just to give a context, the total CO2 emission that we do, thanks to fossil oils and all these industries, 37 billion. So this is roughly 20% of it is due to the wildfires. When we talk about sustainability, and the wildfires caused by electrical reasons. I think SPU is a very good solution to address that and avoid before that is happening.
So speaking of safety and sustainability, regulations play quite a big role in the power grid industry. We are a very highly regulated industry, as we know. How do these regulations influence power quality? Is there a regulation that says that every surge arrestor has to have an SPU? Or is that something that we should perhaps lobby with different governments in different countries that this should definitely happen for the safety and sustainability of our future?
Well, so the answer of your question is yes and no, depending on the region.
Right.
So when we look at the USA and Australia, there are ongoing legislation against wildfire protection, and then SPU is promoted in those regions. And in fact, it is even kind of mandated to the utilities to use SPU-like solutions to avoid wildfires because this is severe. When it comes to European region, we have a way to go. There is no legislation as we are speaking today to utilize solutions, preventive solutions against wildfires. I think we have to act on it as a continent in Europe to protect our nature. This is as critical as SF6 transformation in the network that is ongoing right now. The grid is changing, right? The grid is transitioning right now. This is all nice and fantastic efforts that are being done. And we as Hitachi Energy are contributing to that. Our contribution is not only on product making, but also on influencing on how the legislation should be made. We are more than happy to support utilities and the local organizations to create those kind of legislations. We have a good experience on that. Hopefully, we all together make this continent a better place and less wildfires, which is making all of us really sad during the summer period of time.
Yeah, it's in everyone's interest. Yes, of course. And finally, I think we've got time for one last question. If you were to tell our listeners one thing, if you want them to take away one thing from this episode, what would that be?
What I would say is that the world is changing. The grid is changing. The technologies are changing. We all need to be more adaptive to the new technologies, making sure that things are improving to the right direction. So sometimes catching up the speed of change is hard. I understand that. And we as technology companies, manufacturers, we are taking our part on developing better and greener and faster and easier and more efficient solutions to the grid, to the users. And what we are expecting from everybody is to be mindful about sustainability, be mindful about energy efficiency, and be aware of the fact that there are better solutions in the market. So if we keep doing that and being mindful about what we are installing and what would be the consequences of that 20 years from now, I think the world would be in general a better place. And we would like to be happy to keep our part as Hitachi Energy in this transition, and we will always be there to support our customers.
Thank you very much, Uğur. It's been lovely chatting with you and learning all about capacitors, filters. I particularly enjoyed learning about SPU, Spark Prevention Unit. That seems like a very high-tech, rather important piece of kit that Hitachi Energy came up with. So thank you very much. And that's it for today. You've been listening to Power Pulse. See you next time. And that's it for today. We'll be back soon with some more great content. But before you go, remember to give us a follow so you don't miss an episode. Thanks for tuning in. See you soon. This episode was brought to you by Hitachi Energy. Created, written and hosted by Barbara Freitas-Daniels. Content and script writing by Domenico Menduni. Guest speaker, Uğur Yaşa. Produced and edited by Creative Chimps.